Good morning, class, and welcome to this lesson on Kinematics 5, the equations of kinematics. Today we will know the four kinematic equations and learn a strategy on how to use them. So far in kinematics, we have basically learned what displacement is, we have learned what velocity is, and we have learned what acceleration is. So now, so when things have a velocity, they change their displacement. When things accelerate, they change their velocity and their displacement. All these things are all interrelated. Okay, they're all interrelated, and we need to figure out how do we relate them? How do these things come together? So we have four kinematic equations. We have four kinematic equations. These equations help us relate these things. Okay, I don't care what class you're in, what level you're in. These equations need to be memorized. Okay, so we have velocity equals initial velocity plus acceleration times time. So this little zero down here, this means initial. This means initial. Okay. If there is nothing next to it, we assume final. So like VF. Okay. We have displacement equals 1/2 initial velocity plus final velocity times t. Okay. We have displacement equals initial velocity times time plus 1/2 a t squared, and then we have v squared equals v naught squared plus 2a delta x. Okay, so we have these four equations. We need to know when to use these, okay? And just from personal experience, I think you're going to use this one the most. This is definitely the most that we use in AP Physics at least, and this is in a close second. And then you will use these other ones throughout the course, but just not as much as those two. So if I gave priority, I would definitely do these ones down here. This is how these equations are related. One thing we have to assume that this is for constant acceleration for both of those. Okay. And actually, I just realized right now I made a mistake. These are all assumed to be constant acceleration, all four, because if there's an initial velocity and a final velocity, there has to be some sort of acceleration going on there. Same thing here. So all these assume constant acceleration. Okay, so I'm not going to go into any problems yet or right now, but let's just figure out a strategy for doing kinematic problems first, okay? The first thing you should do when you read a question is you should write down what you are given. You should write down what you are given. I think every single physics teacher teaches this, and I'm going to as well. So if I know, if I have a question given to me, here's a question written out, right? If I have a question given to me and I read the question and I see there's a final velocity of, 10 meters per second, there's an initial velocity of 5 meters per second, and the time is 2 seconds. What is my displacement? Okay, you should always make little charts, something like this, writing out what you know and what you need to find. What you know and what you need to find, because this little process right here will tell you what you know and what you need to find. So if I have initial velocity, final velocity, time, and I'm looking for x, if I go over here, initial velocity, final velocity, time, and now I know that I need to use this equation right here to solve for x. Okay, I need that equation right there to solve for x. So the number one thing you can do is this right here, and honestly, this is just good bookkeeping. It's just being organized on the page so that way you can realize what you're doing with it. So that is a simple thing right there. Have good bookkeeping before you start a problem. Second thing, there are some words, especially there's one word especially that comes up all the time, and that is an object at rest. Okay, an object at rest. Okay, or an object is released. from a certain height. So we have an object at rest, we have an object released. Basically what this is saying is these objects have an initial velocity of 0 meters per second, okay? They are starting off from a standstill. They're starting off from a standstill and then they're moving after it. So if we look at this equation right here, x equals v naught t plus 1 half at squared. Remember I said this is probably going to be our most used equation right here. If this object is released from rest, that means our initial velocity is 0. That means this term right here cancels out because it's just 0. 0 times t is 0. So our new equation is this: x equals 1 half a t squared, which I will say we use very, very often in this course. So just be wary of, there are words that you will find in questions that make us assume certain things. For example, like velocity being 0. And likewise, on the flip end of that, if an object comes to a halt or is stopped, we know that final velocity is equal to 0. Okay, so now we just know that we can assume certain things, we can plug in certain numbers into our equations to simplify them. Okay, because you might look at this equation right here and go, oh man, I don't have initial velocity, so I can't solve this problem if I'm looking for x. But the reality is, if it says it's from rest, we can cancel that term out, which happens a lot. Okay? And the next thing, just another good bookkeeping practice. The first thing you have to do, I told you this already, is determine positive and negative. Okay? If the question says an object is moving to the left, object is moving to the left, okay, and it's slowing down, that means its velocity is going this way and its acceleration is going in the opposite direction. We need to start making some claims here. We need to say, okay, as we write down our things, we're going to put, okay, our initial velocity, I'm going to call to the left positive. Our initial velocity is going to be, I'm just going to make something up, 12 meters per second. And our acceleration is going to be, I'm just making numbers up again, negative 2 meters per second squared, because acceleration is opposite what velocity is. So I just called positive left, I call acceleration negative to the right, and so I just had to make that claim on my own. I had to pick that myself. So once you determine your signs, positive and negative, you need to stick to it. You need to stick to it and make sure that those are consistent throughout the whole problem. So if you can plug in the correct numbers and pick the correct equations, you are already 70% your way through kinematic equations.